Good evening, Professor. This is my personal timetable of this week. So, I'm planning the three different tasks that I'm doing in this week. First is to complete the Corona biosensor paper and also thinking about the characterization date and timings for the SEM, FTIR, and AFM as well and discussed with Prashant to deal with this kind of things remaining in this paper. And the task two is AAO biosensor research. So in the last week, Bruce and Dongmin and me will discuss together, and they went for the SEM. So I'll explain you later in the upcoming slides for the SEM images. And the third one is RF review paper. So Dr. Daniel and Prashant and me already solved this, all the modify the plagiarized content from the paper, and we'll do the typeset in this week. Tomorrow onward, tomorrow we will do this typesetting, and once the typesetting will be done, then we will submit in the respective journal. So this is the antibody that we have ordered. So most probably in the mid of this month we will get this antibody, and also this antigen is also will get in this week, at the end of this week. So once we get this chemicals, so we have to start the chemical reaction and kind of things, and we'll do the experiment and let you know the status of this chemical and the results. So this is the AO biosensor research work. So as we discussed before, you finalize these things to deal with the AO and the graphene oxide and ADC and antibody antigen. So we didn't get the antibody and antigen yet, but we have to clarify the before the first three steps like graphene oxide, EDC, and some washing in techniques. So we went the ASEM measurement. So we found that this one is the experimental plan, like to be use this kind of chemicals in our experiment, AO experiment. So this is the meta surface research plan. So up to this we have checked through the SEM measurement, and skip this one, and I'll skip this one. So this is the preparation for AO for SEM. So we have the six different kind of slides like the substrate to check the SEM images. So this one is the AG protein complex that is having a hydrophilic AO surface. So we found the clear picture of the nanopore, and so it's slightly same as the manufacturing company. They provide the thickness and the height of this nanopore, and this one is the AG protein. So why it comes at the bottom of the AO? Because there is some gap between the glass slide and the AO. So that's why when we put the AG protein complex, it just pass out from this and deposition in between the AO layer and the glass slide. So this one is the sandwich model like image. The first one is the AO nanopore structure, and the second in between this AG protein and the glass. It's a sandwich structure. So its a thickness is basically 500 nanometer, and it's the same as the that we got from the company manufacturing company, the thickness of this AO nanopore. And this one is the AG protein graphene oxide hydrophobic AO surface. So we also got the same clear picture, but there is no gapping because the AG protein is unable to get penetrate into the AO nanopore structure because the surface is hydrophobic. So it's very hard to penetrate the AG protein complex into the pore. So that's why there is no as such gap in between the glass slide and the nanopore, and all the chemical, all the Ag protein just suspended over the surface. So this one is the Ag protein complex, and the glass and AO is already hydrophobic. So the thickness is basically is 1.1 micrometer. So it's very hard thickness of Ag protein. So next time we have to be use the less amount of Ag protein on the surface as per the SEM image. And so there is a gap between AO and a glass slide, the transfer on the glass. So it's a previously cross section of AO on glass deposited with EG for color filtration application. But in this case, when there is no gap, all the Ag protein complexes are suspended on the surface. So in case it comes into the hydrophobic surface, so we have to check the, because our glass surface is hydrophilic and AO is hydrophobic, that's why it doesn't penetrate the Ag protein complex into the pore. So when there is a gap like hydrophilic surfaces means the gap between the AO and the glass is a gap is 50 nanometer, approximately 50 nanometer. Then which means that state 1 is the AO transfer on glass with a small gap, some area touch on glass without gapping, because it means there is a not uniformly deposition, not uniformly stick on the surface, the AO. There is some slight minor gap. That's why the when we mobilize the Ag protein complex, it just simply pass on through the AO and then disperse onto the direct contact with the glass. So it seems like this. The some part of the Ag protein complex surrounded over the surface of AO, and then the bottom of the surface of the AO. So because of having the gap. So after EDC, when we put the EDC, then all the Ag protein complex just surrounded over the AO, because it just pass on to the gapping, filled the gapping Ag protein, and then EDC, and then this is the positive thing also, because when we put the antibodies just stuck on the AG here. So when we use the LSPR measurement, then we found that the different results as compared to the previous ones. So structure after spin coating on AO. So spin coating, if we put the spin coating, then all the is without, when we put the without gapping, it means like there is no gap, then we it comes over the surface. But if it is having a gap, then the Ag protein submerged the AO layer and to fall onto the surface. So the Ag nanoparticle are embedded inside protein layer, and the coated protein layer is thicker than the AO layer. So nanopore structure is covered by the Ag protein. So by using this SEM, we learned that we have to take this minor and minor Ag sample, Ag protein complex sample on the surface. So AO film transferred on glass is not stable, so easy to move by liquid. Is already is on the liquid glass. So the nanoparticle size is around 20 nanometer, fill the Ag protein layer, and Ag cannot be observed on Ag protein complex layer surface. And the graphene oxide is too thin, is very 1 nanometer, that is spared in the coated glass, because the graphene oxide is already having a very minor thin layer. So it's very hard to measure, but it's not more than the 1 nanometer. So after once we get the chemicals, and also we are studying the SEM images as well. So we have to make some implementation, some modification of our research plan of AO. And in this week we have to do this, and also simultaneously I'm working on review paper, that is RF review paper. So me, Dr. Daniel, and Prashant will do together to minimize or to just modify the plagiarized content. So we already did this, and today I just combine all the our content in one paper, and to check the mm, uh, just formatting and like to use the typesetter. So I have today I started the typesetting setting things. So tomorrow maybe I'll finish the typesetting, and once I did finish this, then I'll let you know, and also ready the paper for the respective journal to submission, and that's all, sir. Thank you.